This is a continuation of section 2.5. These are not in your notes, so as you are watching this video, you're going to have to add these in. But it's a series of proofs that get us to practice the concepts that we are modeling so far in the homework and the previous videos. I'm actually going to start down here with one that we're a little bit more familiar with, kind of these algebraic proofs almost. Here it says given that Km equals 35, can we prove that Kl equals 15? Shouldn't be too difficult of a task. First thing we're going to do is say 1, Km is equal to 35, and again that's given. It's always our first statement is what they tell you in the given. Okay. Now, obviously we would know that we would take 2x minus 5 plus 2x equals 35. Okay. But we'll walk through the logic of that, the step-by-step discussion or argument that says, why can't I do that? Okay. So, if you remember our steps, first thing we write given, second thing look for vocabulary. There's no vocabulary here, so we can skip that. Next thing we do is look at our picture and think about, well, what does our picture show us? And to me, I see 3 collinear points. I see segments. I think segment addition postulate. So I say KL plus LM should equal KM. And I just tell people then, why do I know that? Why do I know that that's true? Because we have the segment addition postulate that says exactly that. Okay. If you remember, segment addition postulate, it actually says if A, B, and C are collinear with B between A and C, then AB plus BC equals AC. This says the exact same thing, but it's K, L, and M instead. Now that we know that, now it's a matter of using the information that we see in our picture and information that we were provided in our given, along with what we came up with, and create a new statement. Something that is to be true, but is new from anything that we already have here. Okay? So one thing that we know is that KL is being represented as 2x minus 5. Okay? We know that LM is being represented as 2x. I'm just putting those in parentheses right now. It's not 100% necessary that you do that. I'm just showing you that those were the 2 individual small parts. We're going to add those together, and they should equal Km, which is then by 35. All we did there was we took statement 2 and rewrote KL with what it was equal to. We wrote LM with what it was equal to, and Km with what it was equal to. So we replace something with what it was equal to, and that is always substitution. Step 4, and we can get very, very detailed with this stuff. I'm going to go ahead and write it this way. 2x plus 2x minus 5 equals 35. And that is really what I've done here is I've moved the 2 x's, so that was the commutative property. And I also regrouped the 2 x's. So I'm just going to say commutative and associative there in that same step. Step 5, I'm going to rewrite this as 4x minus 5 equals 35. Okay. Anything in Math Excel is going to say that is the distributive property, because we really did this. We took 2x plus 2x and realized, well, they both have an x in them. So we'll pull that x out, and then that's x times 4, which I'm going to rewrite as 4x. They consider this whole thing distributive. The idea is that we factored out this x so we can add the coefficients or the constants, and that's the reverse of distributive property, so that's what they call that. If you want to call it, as we're doing things in class, you want to call it combined like terms, because you're familiar with that, that is fine. Just know that when you're in Math Excel and you think the answer should be combined like terms, and combined like terms isn't an option, that will be an option. I'm going to add 5 to both sides. So then this gives me, so 4x equals 40. That when I added 5, that was the addition property of equality. Just trying to keep, add something to both sides makes it stay equal. Now I'm going to divide both sides by 4. So here's me x equals 10. Not substitution. Let's do it this way. Obviously we divided. Call it division. Sometimes it's called substitution because we substituted 4x with x and 40 with 10. That's down the road. That's division. You divided both sides. Now what I'm going to do is I'm going to say, okay, so if that was x, but that's not what they want to be proved. They want to prove this. So I'm going to bring back in what KL was. So KL was equal to 2x minus 5. We can actually say, that was given information as well. It was provided in the picture. And now, well, if KL equals 2x minus 5, but I just figured out that x was 10. Now that's substitution. We can say now here in step 10, KL, well, 2 times 10 is 20 minus 5 is 15. We can say there it's actually the best answer is substitution as well. This side got substituted with 15 with what it was equal to. If you're a person that says, based on maybe just order of operations, you can also go, combine like terms. Those are all maybe logical reasons of why 2 times 10 minus 5 goes down to 15. But this is something that we should maybe be familiar with. And now, like I said, as we go through them, sometimes let's see here, like this step sometimes is skipped. Just depending on if you're writing a proof, you write it for a particular audience. So if I was writing this for, let's say, a graduate level math course, so you've got a college degree in math, and now you're going back to get more math, we probably wouldn't be doing a lot of this stuff because at that stage they have the knowledge that they know that this is already in there. I don't need to make that argument to them. I don't need to explain that stuff to them. But if we're talking to 9th grade, 10th grade students who just finished their first year of algebra, maybe this is necessary. Let's come up to this example here. So here, the given and the prove are pretty basic statements. They filled a lot of stuff in here for us. It says angle CDF as provided, so that just means they've given you a picture, and there must be then some stuff from that picture that we can gain for the mere fact that they don't really tell us much more in the given. Okay, they want us to prove that x is 40. So we've got, and I know I don't have these labeled very well, but step 1. Step 1. Okay, statement 1, reason 1. Statement 2 says angle CDE and angle EDF are supplementary. Okay, well, how do I know that these are supplementary? If we look at these two angles here, that angle there and that angle there, we know that they are supplementary, okay, because they are two angles, they're adjacent, and they form a straight line, that line right there. So that right there tells us that we know these should be supplementary because they form, and if remember that angle set, we call that a linear pair because they form that line. Okay, so that's nice. Okay, this was, it says angles that form a linear pair are supplementary. If you remember what that was, that's actually called the linear pair postulate. So if you want to call it that, instead of writing out this phrase, that's fine. Okay. But here's the idea. Here's what happens. And that's essentially, I've already filled that stuff in. We'll use that up in the next example. But now it says we get this line here. Well, where does that line come from? That line comes from the fact that we introduced a vocabulary word. Okay? If you go back to our series of steps of how we do a proof, we write our given down. We did that. Okay? We look in that given if there's any vocabulary. No, there's not. So I go to my picture and look at my picture. Okay? And from my picture, I can generate a vocabulary word. I know these two angles have to be supplementary. They form that straight line. They're a linear pair. So now that I've introduced a vocabulary, whether I'm given the vocabulary at the onset or I introduce it at any point, I then have to tell in the coming step, what does that vocabulary word really mean to me? Well, if I have two angles that are supplementary, by definition, it means those angles add up to 180 degrees. So that's what we're seeing with those two angles. They're adding up to 180 degrees. Okay, so this phrase, this English phrase, is able to be converted now into something algebraic. The reason for that is the definition of supplementary angles. Again, you could write out two angles that are supplementary, add up to 180 if you wanted to. That would be actual definition. If you looked in the glossary, look for supplementary angles. The phrase that it says would be two adjacent angles that just two angles that add up to 180 degrees. It won't say anything about adjacent or anything. They don't have to be adjacent. So now, where do I go from there? Well, look at what they did here. CDE, and now it's something completely different. It's X. Well, let's come over here. Is CDE, is that angle X? So what they do, they just replaced that phrase with what it was equal to. Let's look at EDF. EDF is this one, 3x plus 20. They replaced that with what it was equal to. So they replaced this blue thing with x, and then this green thing with 3x plus 20. Well, when I replace something with what it's equal to, simple substitution. Okay. Now in this stage, this is where I think they could be more detailed. Okay. If you think really what's going on here is that they're going to regroup these two, they're going to associate property those two, and then combine like terms, which they could get further down into distributive property if you want to. I'm just going to say from this step here to 4x plus 20, so x plus 3x plus 20 down to 4x plus 20, let's just call that combine like terms. Okay. Now, you could call it substitution because we replaced x plus 3x with what it was equal to. You can do it that way. Combine like terms is fine though. Now what we're going to try to do is isolate the 4x. So they take and get rid of this 20 on both sides. So it leaves you 4x equals 160. Well, if I get rid of something from both sides, that's the subtraction property of equality. And now here, we get 4x equals 160. Divide both sides by 4. We get x equals 40. So that is the division property of equality. And once we get a line down here in our statements that matches up to what we wanted to prove, we know we're done. Alright, so these types of questions here then are really what we want to kind of target in this class. Okay, these kind of build us to it because these are obviously algebraic and we have an understanding of our algebra concepts and our rules and principles and that kind of stuff. So if we can do those, then it's an easier transition to being able to do this. Okay, so what I'm going to do is write down my given. So I say angle 1 and angle 2 form a linear pair, and it also says Ki bisects angle HKJ. They want us to prove that angle 2 is a right angle. Okay. Maybe hopefully it's not something that we need to remember, but angle 2, can we end up showing in some fashion, how do I know it's a right angle? Well, at some point, I'm going to have to, because of the definition of right angle says it's an angle whose measurement is 90 degrees. So somewhere in this proof, that needs to show up. And once that shows up, I then know I've gotten down to where I can argue it to be a right angle. So first thing we're going to do is we're going to go through, so that was our given, and we've got vocabulary words here in our given. Linear pair is a vocabulary word, okay? Now linear pair, it's a little bit different of a vocabulary word than most that we see in proofs. It's the one that you're really never going to say definition of a linear pair over here. But what angle 1 and angle 2 allow me to do, if I know they form a linear pair, is say that angle 1 and angle 2 are supplementary. Okay? When you say that, when you have a linear pair, you can always then immediately say that the two angles that are being discussed as a linear pair are automatically supplementary. Those two things always go together. And that is because of what we call the linear pair postulate. Which, if you remember what the linear pair postulate, we just talked about it down here, it's that angles that form a linear pair are supplementary. If you wanted to write it out in full text. Okay, so the next step, you have a choice now. So we got rid of this vocabulary word. We still have this vocabulary word, and we also now have this vocabulary word. Okay, so all we've got to do is make sure that we at some point talk about all of them. So let's just go talk about supplementary, since we're on that concept right now from our last example. If I have two angles that are supplementary, I can automatically say that they add up to 180 degrees. And that's going to be definition of supplementary angles. So what happens here, and you think about it in the other example we did, whenever you see linear pair, you're always going to say, well, supplementary. And once you say supplementary, you're always going to say, then that gives me two things that add up to 180. Always. Okay? Let's go down to this example that we went down through here. Did they say supplementary? And then go straight to two things that add up to 180? Okay? So that's something to think about as we do proofs. A lot of times, steps come in chunks. Okay? This here, that word right there is an identifier essentially for this chunk of phrases here. Next thing we're going to look at this is that KI bisects, there's another vocabulary, KI bisects angle HKJ. HKJ. So HKJ is that angle. KI bisects it. Well, if you remember what bisects means, it means we have two angles that end up being the same. They end up being congruent. So what I'm going to be able to do is say that measure, actually I'm going to say, let's go measure. That's fine. We'll go measure of angle HKI equals the measure of angle JKI. And that's the definition of an angle bisector. Okay. Now, when I look at measure of angle HKI and measure of angle IKJ, we can write them that way. It's up to you, but HKI is also being called angle 1. So let's maybe write it that way. Let's write here. It's just going to make the next step a little bit easier. And that's an identifier of, well, how did you know to use angle 1 and angle 2? Well, up here, they're using 1 and 2 in my picture, and usually that's an identifier that you don't have to use HKI. But I also saw that I had 1 and 2 written here previously. And instead of writing HKI and remembering that that is 1, I might as well write them all in the same terms. Okay, so now what's nice about this is we've exhausted all our vocabulary. We talked about linear pair, talked about bisects, talked about supplementary. Now it's a matter of stitching some of these together to come up with a new argument. Okay, and what I see right away, and you can do this one of two ways, but I want angle 2 to be left in here. Okay, so right now 1 and 2 are the same thing. What I'm actually going to do is I'm going to rewrite statement number 3, but I'm going to write it using this logic right here. So 1 plus 2 is 180, but 1 and 2 are the same thing. Can I rewrite that as measure of angle 2 plus measure of angle 2 equals 180? And the only thing I did here is right there and right there. I told you 3 and 5 were going to be the same thing, and all I did is I took this green thing here and replaced it with that green thing. And why can I do that? Because right there I told you, or we were told, we were found out through the bisects term that they were the same. So if they're the same, I can replace one with the other anytime I want to. And that's substitution. Okay. Now, what's nice, let me add those together. You got 2 measure of angle 2's. My measure of angle 2 here is kind of like a variable. Okay? It's a symbol for a number that I'm not sure of. So I got 2 of those, so that's combined like terms. Okay, you might just call it addition. Okay, it's not an addition property of equality because I didn't add to both sides. I just combined these values. Now I can divide both sides by 2. Divide by 2 gives me measure of angle 2. Divide this by 2 gives me 90. Sometimes you like to tell people what you divided by. And now, if I've just shown measure of angle 2 is 90 degrees, that's what we said we had to show. So now I can say angle 2 is a right angle, because I know when I have an angle of 90 degrees, I can classify it as a right angle. What thing allows me to classify? Their definitions. Well, what would I class? How do I know what to classify it as a right angle? Is because the definition of a right angle allows me to look at angles and then decipher, does it belong in this class or does it not belong in that class? So that, and so here's not a difficult concept. Think about this. You've got a straight line. You've got a linear pair. And you know linear pairs are up to 180 degrees, or straight lines are 180 degrees. And I say, well, this here bisects it, cuts them in half. What are both these? They both have to be 90 degrees. So they're both right angles. Okay? But this is the argument without any gaps of why that's true. All right, so this question here, let's say, so we got angle WXY is a right angle, and angle 1 is congruent to angle 3. Okay, so that's given. So first thing I want to do, I'm going to come through here, and I'm actually going to, whenever you see a congruency in a given statement, go ahead and draw it in your picture. I'm going to draw those in. We're going to have to show somehow that angle 1 and angle 2 are complementary. That means they add up to 90 degrees. So at some point, we're going to have to see over here in our left-hand column that measure of angle 1 plus measure of angle 2 equals 90, and that then allows us to say they're complementary. So that's kind of where I'm trying to try to take this. All right, but the way I'm going to get there is by using the information that's here. WXY is a right angle. So WXY measure of angle WXY is a right angle, so equals 90 degrees. So whenever I see a vocabulary word, what does that vocabulary word tell me for my particular problem? Right angle, my particular problem is angle at WXY, measure angle WXY equals 90. So that's the definition of a right angle. Okay. I've exhausted vocabulary. Okay. Now it's a matter of looking at your picture. Okay. And we'll get better at this, but I know that when I look at measure of angle WXY, they told me it was 90, but it's being composed of multiple angles here. Is it fair to say that measure of angle 2 plus the measure of angle 3 equals the measure of angle WXY? 2 plus 3 gives me this whole angle here. That's the angle addition postulate. And that's what I told you in those 7 steps previously in this section of how we do a proof, is that once you have exhausted all of your vocabulary, you look at your picture. What's my picture dealing with? Angles or segments? If it's angles, that's what we got going on here, you're probably going to use angle addition postulate somehow. It makes sense to add 2 and 3 together. Why does that make sense? Because now I can say, step 4, let's use these 2 together. WXY is 90. I can replace that right now with 90. So I'll say measure of angle 2 plus measure of angle 3 equals 90. Okay, all that is substitution. Now think about what we're trying to get to. We're trying to get to 1 plus 2 equals 90. Right now we got 2 plus 3 is 90. Is there a way I can replace 3 with 1? 3, because if I get that replaced with 1, it matches up to what I wanted to say here. And right there is how I do it. They told me angle 1 and angle 3 are actually congruent. So what I'm going to do now the way I've got this set up, and this is important. This is kind of almost a structural step, a procedural step almost. Right now this is a shape. These 2 shapes are congruent. Right now these are numbers. I don't know what these numbers are, but measure angle 2, measure angle 3, those are symbols for values that when added together equal 90. So I can't replace a shape with a number or a number with a shape. But if I know the 2 angles are congruent, I should know that their measurements are equal. So this step here and that step there are tied together. If I start with congruency, I can go to equality, and it's the definition of congruency allows me to do that. Okay. If you're in Math Excel, some of the examples that we maybe see, or the drop-down windows, or maybe things they've already filled in for us, says that congruent segments have equal lengths. That is the definition of congruency for congruent segments. But now it allows me to say, okay, wherever I see 3, I can replace it with 1. So I'm going to rewrite step 4 as step 6, but wherever I see 3, I'm going to replace it with measure of angle 1. Replacing something with what it's equal to is substitution. And now I see 2 plus 1 equals 90. That's what we wanted. Now I can go ahead and say, well, if I have 2 angles out to 90, those 2 angles must be complementary. And the reason, so I had 2 angles, I just classified them as complementary. So whenever you classify something, you're doing that because you know the definition of what you just classified it as. So complementary, definition of complementary angles. These types of proofs, guys, they're initially, there's going to be several different tiers of students. Some people are they're gonna get this right away. It's gonna make perfect sense right away. Some people are gonna struggle with it, okay, but they're gonna push through and they'll get it. It'll sink in. There's another group that they're gonna work and they're gonna work and they're gonna work, and it's not gonna make a whole lot of sense until one day a light bulb goes off and everything will click. Okay, so if it doesn't make sense right away, keep plugging away. All right, you cannot just give up on it because it doesn't make sense right now. keep plugging away, keep trying to see the different relationships. One of the reasons because I know this will exist, I know we'll have people struggle with this. This is why I give you this, okay? Because if it doesn't click right away, this at least will help you get things on paper, okay?